In this video, we're going to work on solving perimeter formula applications. First, identify the shape in each situation, and then find the shape's formula. This isn't always obvious, but if you draw a picture, this might help. And then we need to determine which variable is missing and solve for it. Use the given values to solve. So you'll probably have to do some substitutions. In example 1, the perimeter of a rectangular jogging trail is 5.4 miles. If one side of the trail is 1.3 miles, what are the lengths of each side of the trail? We have to determine the shape, and it gives us what the shape is. So we know that the jogging trail is a rectangle. We also know that one side is 1.3 miles. And this is not to scale, but we just need to be able to draw the situation. Well, if one side of the trail is 1.3, we know that over here on the other opposite side is also 1.3 miles if it is a rectangle. So these are the sides I don't know, and I'm going to identify those with an X. Now remember, a perimeter of any shape is the outside edge, but in this particular instance it's a rectangle, so we know two sides match, and then the other two sides match, or they're the same length. This means that if we add them all up, we should have two 1.3 mile sides plus two unknown sides. And we also are given the total perimeter, which is 5.4 miles. So we know this is equal to 2 times 1.3 plus 2 times the unknown sides. So now we just solve for x. 2 times 1.3 is 2.6. The total perimeter is 5.4, and then we have the two unknown sides. If I subtract 2.6 from both sides, 2.8 equals 2x. Now I need to divide both sides by 2, and x is equal to 1.4. So each one of these sides equals 1.4 miles. Now if you were to add these all up, they should add up to 5.4 miles, and you can check that if you'd like. In example 2, a family with young children decide to walk around a circular path in a park. There is a parking lot at the edge of the park. To do a full loop, the family must walk 2.8 miles. At the halfway mark, one child starts screaming because they got a bee sting. They decide to walk straight back to their car instead of finishing the loop. How far do they have to walk to get back to their car? Now, this one, again, might be very confusing without a picture. So we're going to draw a circle because it says that it's a circular path. And we'll say that this right here is the parking lot. So we'll say they park their car right here, and they start walking around the loop. And at the halfway mark, the kid gets the bee sting and starts screaming to go back. We know that the total loop was 2.8 miles, and they're going to go straight through back to their car. So we're looking at a circle formula. So the circumference of a circle is 2 pi r. And remember, 2 radiuses equal a diameter. And this right here is our diameter. So we are needing to find how far they need to walk back to the car, which happens to be the diameter. We know the circumference, C equals 2.8 miles, so we'll replace C with 2.8. And 2 pi is given, like we know what 2 pi is, and we need to find the radius, because if we know the radius, we can double it to get the diameter. So I'm going to divide by 2 pi on both sides. And this is one that you'll probably have to use your calculator for if you haven't memorized pi to like 3.141592653, etc. And so r is going to be 2.8 divided by 2 pi. So take a second to put that in your calculator and then start the video again. If you took a second to calculate this, you should have found r to be about 0.445. So if you were to double that, 2 times 0.445 should give you, rounded to the nearest tenth of a mile, your diameter. So 0.9 miles to return to the car. If they traveled half the way, that means that, just for context, we have 1.4 miles traveled in and 0.9 miles to return to their car, so it is actually substantially less. It's half a mile less to go straight back to the car instead of going the rest of the way around the circle. If they're trying to travel through a whole bunch of mountainous terrain here, that might not be the best option, but there you go. That's how you solve that problem.